This is section 1.4 in college algebra, types of functions. And at this point, we really are only going to divide things into three categories. We would get into a lot more detail in other chapters, but for right now, things are either going to be a constant function, a linear function, or nonlinear, which will take care of everything else. So for the constant function, it's f of x equals b, or y equals some number. Here's some examples. Y equals 3, f of x equals -5. There's no x term. It is a constant function, and it is a horizontal line. Linear functions, f of x equals ax plus b. You're probably used to thinking of it as mx plus b. A would be the slope in this form. B would be the y-intercept. So you might have y equals 2x plus 3, y equals -5x minus 10. Those are examples. Nonlinear are things that are not straight lines at this point. And you want to think about that they would have an exponent on x that's larger than 1. So x squared plus 2, 3x cubed minus 5, those would be some examples of that. So in your homework, you might be asked to determine whether something is linear, nonlinear, or constant. Here would be an example where you would decide this is linear. The exponent on x is a 1, and it's not usually written in there. It would be understood. You could write it in there for yourself, but that's an understood 1. This one, 3x squared minus 2, is nonlinear. That exponent is larger than 1. And f of x equals 5 would be constant. There is no x term there. All right. There's 4 representations of a linear function. And you might hear about verbal, where it's really a sentence, an English sentence that talks about the mathematical sentence. Multiply the input x by 3/2 and add 3 to get the output y. So that's a verbal representation. The symbolic would be to put that in your mathematical sentence. F of x equals 3/2 x plus 3, or with decimals you could have 1.5x plus 3. Numerical, you would have some x values and put the y values. And if we notice here, the x's are all increasing by 1 as we go down. The y values, as they're determined, are increasing by 1.5. That's another thing that's important, because the slope, as x increases by 1, y increases by 1.5, so we do have a linear equation. Graphically, we have plotted these points, and we have a graphical representation. So those are the 4 ways that might be discussed in your book. Increasing and decreasing functions. All right, so when you're looking at a graph, you want to look at it from left to right, from left to right. And the graph is increasing. It's rising from left to right. So that means it's increasing. So in other words, if it's a curve, it's going uphill. In this one, from left to right, it's falling and it's downhill. So that is decreasing. In some, you may have something that does both. So here's a place where it changes. From here to here, it's decreasing. From here to here, it's increasing. So you'll be asked to talk about where functions are increasing and decreasing. So you want to look for where is it rising or where is it falling. If it's doing both, you find where the point is of change. So the other thing that we need to talk about is interval versus inequality as far as notation when you are talking about a space or an interval in the graph. So inequality would be written with your little inequality signs, and you might have x is between -2 and 2. So x is greater than -2 but less than 2. But I like to say x is between these. When you put it in interval notation, you have parentheses, -2, 2. We have parentheses because we do not have an equals under here. If we do, then that gets a bracket. So the symbol alone without the equals, you get parentheses. And if this is on a graph, you might see it like that. All right, on this one, -1 less than x less than or equal to 3. That has the equals. So that end gets a bracket, this end gets parentheses. It's a half open interval here, and here's a bracket. What that means is -1 is a boundary for this, but it's not included in the actual part. This one has equals on both sides, so we have brackets on both sides, brackets there. X is greater than -3. If we're going to put that in interval notation, you start at -3, comma, and you go to infinity because x is everything greater than -3. And on your graph, you would have a parenthesis here and a straight line with an arrow going the whole way. How about x is less than or equal to 1? That means everything to the left of 1. So you would have negative infinity, so from the left all the way up to 1, and then a bracket. All right? So if you had the entire number line or an infinite interval, this is what it would look like. Negative infinity less than x less than positive infinity, or in the parentheses like that, because you can never reach infinity. So you would not have a bracket on those. And the last things that we need to talk about are slope, which is average rate of change. And most of you are familiar with slope, where it is about the change in y over the change in x. So as y increases, x increases as well. So that is a formula that you're probably familiar with, and we'll talk about that in our homework. Something you're not quite familiar with is the difference quotient. And this is often used in calculus to calculate rates of change. So if you were moving on, you would certainly see this, or at least have a sense of this as you move to a little bit more complex ideas. It's the slope of a secant line, a line that goes through something. So if you look here at this picture, we have a line, we have 2 points. We don't know what these points are. So if I just call this x, comma, f of x, that's like xy. And then I go this far to the right, a distance of h. Then would it make sense that this is x plus h, and this would be f of x plus h? So hopefully that kind of makes sense. We're just letting that be the names of those points. Then if I did the slope formula, I have y minus y over x minus x. So I just took the y parts and subtracted them, f of x plus h minus f of x, and then I did the same with the x parts. Now on the bottom, those x's cancel out. So I am left with this formula. The difference quotient is f of x plus h minus f of x over h. Here's an example of what you might be asked to do. So you're given an equation, f of x equals 8x plus 5. If this is linear, do you already know what the slope is? Yes, we do. The slope is 8. So that's going to be the difference quotient. For a linear, you could see that right away, but you need to be able to do this and figure this out, because you might have to do it with something other than linear. All right, there's 2 parts on the top, f of x plus h, so we figure that out first. Means we plug in x plus h for x, and then we simplify 8x plus 8h plus 5. F of x equals 8x plus 5. That's your original. All right, so I've got my yellow part here minus my blue part here. And then, because I have a minus there, that becomes minus, that becomes minus. That's pretty important. That'll make a difference if you forget that. Well, then a lot of things begin to cancel out. This 8x and this minus 8x. This minus 5 and this plus 5. This h and that h can go away. And what are we left with? just 8. So the difference quotient is 8. Those are the notes that will help you with the homework. Let's look at the homework questions. These are the blank problems that you have to look at. They will be like your homework questions. Number 1, find the slope of the line that goes through the given points. And I've reminded you of the formula right here, y2 minus y1 over x2 minus x1. It doesn't matter which one you designate as your 1s and your 2s. I usually start this way. This is x1, y1, x2, y2, but it doesn't matter. You could do that backwards. But if we do it this way, we have negative 3 minus 9 over 5 minus 2. That's negative 12 over 3, so our slope is negative 4. We would choose this, and we would fill this in with our negative 4. Same thing on number 2. We've got this. We're going to do the same thing. Negative 10 minus a negative 1 over negative 4 minus a negative 7. So we have negative 9 over 3, which is negative 3. So in this box, we would have negative 3. All right. Number 3, same idea. Negative 10 minus a negative 7 over 6 minus 6. We end up with negative 3 over 0. We can never have 0 in the bottom. That gives us an undefined value. So this is your choice. The slope is undefined. Anytime you see the x repeated, that's what you're going to get. You're going to have a vertical line, and it will be an undefined slope. Number 4. This is a graphical representation of buying X square yards of carpet, and this is your cost. All right, so it says what is the slope of the graph? Well, choose 2 points. I chose these. I don't think that they were on there, so I just happened to choose 4 and 7, and I said what were the ordered pair there? This is 4 comma 60. This is 7. Whoops, I put it on 8, sorry. 7 comma, and it looks like these hash marks are going by 15, and so that was 105. You could pick any numbers, whatever is easiest for you, and then you do y minus y over x minus x. That's 45 over 3, so it's 15. So the slope is 15. What does the slope represent? Okay, it's the cost per square yard of carpet. Okay, the cost per square yard, because it's a comparison. How does the cost change based on the square yard? All right, let's look at this number 5. The winning times for the 200-meter dash can be approximated by f of x equals this plus this, where x is the year. What is the slope of f? Well, you can pull that out of the equation because you know it's like mx plus b. So the slope is negative 0.05289. Now the question asks you to interpret the slope. What is it saying about every year? Well, the negative tells us that it's decreasing. All right? So the winning time decreases by, now, when you say it decreases, you've already taken care of the negative. So note that this doesn't have the negative on it. This one says decreases by negative. Don't be confused by that. If you decrease, you don't also have a negative. We're decreasing by this amount. You've taken care of the negative by using the word decrease. Over a 4-year period of time, what are the winning times expected to do? Well, x is the year, so take 4, multiply it by the negative 0.05289, and you get this value. So over a 4-year period, the winning times will decrease by, again, use the positive because you've already used the word decrease, and that took care of the negative. Number 6 was finding a difference quotient. Again, you should realize your answer is going to be -2. That's the slope of that line. But if we are to do it like this, you want to be able to say f of x plus h, plug x plus h in for that, and you get this value. Here's your original. Subtract them. Things cancel out, and you get the -2. Determine if f is a linear or nonlinear function. 2x plus 1. So if you have 2x plus 1, what's the understood exponent there? It's a 1, and when exponent is a 1, it is linear. So this is linear. Is it a constant function? No, because it does have the x, so it's not a constant function. And then it says which must be the graph. Well, let's think about what we could eliminate. This is an absolute value. This is a parabola. These are both lines, but what was the slope for this one? A +2, increasing. This one's decreasing. That'd be a negative slope, so it's this one right here. Same question here. It is linear, but it's constant. There's no x there, so that would be your choice. And then if you graphed it, f of x equals -3, you're going to get this horizontal line. It would not be this, and it would not be a vertical line. On this one, x squared plus 2, remember if you have an exponent that's bigger than 1 on x, you have a nonlinear function. And that would be this parabola right here. X squared is a parabola. Okay. This one, 2 square roots of x. Now, this is like 2x to the 1/2. You haven't gotten that yet, but just to tie that into the exponent not being 1, that's what we need to remember. That's an exponent other than 1. So this is nonlinear. This is actually the way this function looks. We would know it wasn't this or this. You might not realize this is part of a parabola, and this is 2 square roots of x. You could do that on your calculator. We should get really used to doing that if you're not sure about something. I'm going to clear that one, and I'm going to put 2 second square root x, and then I'm going to do a zoom 6, which gives me the standard window. And you can tell, you don't have a standard window here, but you can tell this is the graph. So again, you could throw that in the calculator and make sure. All right, now we've got a few talking about interval notation and inequality. We have x is greater than or equal to -1. So if we're going to put that in interval, first of all, we note that we should have a bracket. So bracket -1, comma, and we go all the way to infinity. All right, we're going from this one. X is between -5 and 5. This has an equals under it. This one does not. So we have a parentheses on this end, a bracket on this end. All x is such that 1 is less than or equal to x. So x is bigger than 1. We start at 1 because it had an equals, and we go all the way to infinity, parentheses. All right. This one's a little different. We have an or in here. X is less than 3, or x is greater than or equal to 7. So on the x is less than 3, we start at -infinity, we come up to 3. Both of those are in parentheses. We didn't have an equals. X is greater than or equal to 7. Start at 7 with a bracket, comma, parentheses, and we have a U sign in between. All right? Number 5. We're talking about increase and decrease here. So what you want to think about is, where does this change? This thing's decreasing, decreasing, decreasing. Bam, you hit the bottom of it, it changes direction and starts to increase. So that point is 0, -1. That's where it changes. That's what we need to do first. All right, where is it increasing? It's increasing on that curve. And you talk about the x values. So that's from 0 to forever, so that'd be 0, infinity. Where is it decreasing? It's decreasing here. From left to right, that's decreasing. From negative infinity to 0. Okay? Where is this one increasing and decreasing? So what I did, I highlighted the parts where it's rising, that's increasing, and I highlighted in blue where it's decreasing. I marked with a red hash mark here the point where it changes. That's the max of that little curve. This is the min of that little curve. So this one's at negative 3, 0. This one is at 1, negative 3. So now it's a little easier to see where is it increasing. It's increasing, and I might also write a negative infinity out there and a positive infinity out there so that we can go along the line. So from negative infinity to negative 3, it is increasing. And I just changed this, I just saw that I had looked at this graph, and I guess when I first wrote the numbers, I wasn't realizing this is really an important mistake that I made that you might make as well. So I'm actually glad that I did that and caught it. This is not by ones. This increment is by 2, so that's 2 there. So that'd be 2, negative 6, and here that'd be 2, 4, 6. That'd be a negative 6, 0. So be careful to look at the scale on your graph. Actually, that is not going by 2's there. I still have it wrong. So if that's going by 50, that's 10, 20, 30. So those are by 10s. So that'd be 10, 20, 30. It doesn't matter. We're not going to use that, but I wanted to get it right. Okay, so where is it increasing? From negative infinity to negative 6, and from 2 to infinity. So that would be that one. Remember, you're only worried about the x values. Where is it decreasing? From negative 6 to 2. X values. All right. And then we had another difference quotient. And I think that we've done that. So you've got that on the lecture notes. But if you needed to see it again, there it is worked out, where you have the f of x plus h, which is this one, and you have the f of x, and you are subtracting that from the f of x plus h, and then canceling out the parts that do cancel. So I think that will get you going on section 1-4.